Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Last video, we have finalized the submit for the command line options that we just added. And now we want to associate the source code lines with the assembler instructions. Okay. Okay. So we have ASM match ASM. Okay, how do we do this? Okay, so okay. So we have ASM instruction, and that has an address. Here. ASM instruction. Yes. Okay, so here's an instruction. We have ASM instruction variants. So this one, okay, this one is part of functions. Okay, so yeah, so our function has the knowledge of this function. For starters, I think we should move these guys here to function types dot header. I think. By the way, there was one more thing that I wanted to look into. Oh wow, that error is hard. Okay. Includes includes variants, includes vector. Variant, vector, and string. Back to function. Remove string, variant, vector, and array. What about map? path map. Let's create a new common types. Common types .h. Reloads. Common. Namespace unassemblize. Then we move these guys in here. Common types. Includes common types. Common types. Executable types .h. Common types. Oof. Oof. Stop it. Stop. Okay, what's the problem here? Why is this? Why is this not recognized? std int. Okay, looks like this needs to include executable. Okay. So here in function, I was wondering if we could get rid of this intermediate. The reason to keep this small is that we have quite a number of instances. So the smaller we can make it, the better. So I would say can read 64 bytes, which is exactly one cache line. It's not a bad size. But so this intermediate here, basically well, we can't get rid of this. It would be nice if we could move the function here, the function pointer. But that is not possible because then it would mean that the function intermediate would always be locked to one function. Yeah. No, I guess then we keep it like this. Yeah. Yeah. Good, so function times. Common types. Okay, move types, move some types to function types .h. Good. Okay, back to our previous thoughts. So good. So we have function types. Yeah. Good. So we have our ASM instruction that has the address, and our function has the instructions list here. Yeah, get instructions. Yeah, good. So this a runner is accessing this. Yeah, instructions and comparison as well. Okay. Okay. Okay, so basically we need to take one instruction variance vector and we need to instruction. Yeah. Okay, so the problem is, so we could accompany this variant vector here with a vector with the same indices, the same count, same indices, and then wherever there is an instruction here on the side, then on the other vector we then have information about the C++ source code line. But that is bad because that would not be compatible with the ASM instruction pair, with this one here. So it needs to be compatible with ASM comparison records and ASM instruction variants. These two things needs to be compatible. Which means it needs to be part of ASM instruction, but that's not nice. Well, it does have the address, so it can always look up C++, but it's expensive lookup. Or is it not? Let's go to PDB reader. Right, so how can we build this fast? Yeah, I don't know. Shit. Um, okay, where are our functions built? Oops. Function. Jesus. Okay, they're here. Functions. Where are these built? Build function match collection. Function match collection. Right. Yeah, okay. Okay, so we have ASM instruction variants and ASM instruction, ASM comparison records. When we build the, let's go to runner. When we Build bundles, yeah. So when we build bundles, then we access function info vector build bundles functions function name to function match collection. Okay, there's a lot of question marks. I don't know yet how to associate assembler instructions with source lines. I mean, we have this information in the PDB. We can access it. That's not the problem. String to index map. What is that for? Function name to index. Function name to index. Yeah. Okay, so our function info vector, this one, it contains a PDB function info which contains the source lines here with line number, offset, and length. this is the PDB function info. It's quite big. Why is this so big? Function info vector. I think we could make this thing smaller. Like realistically, this one can be smaller. Offsets. Will we ever have a CPP file with more than 65,000 lines of code? Probably not. So 16. Offsets can probably also be 16. Just like that, we halve the size of it. Okay, so when we have access to the PDB function info, yeah, then PDB function info vector. We need to functions. Okay, so I don't know how to organize the data. It needs to be in sync with this one. But also with the other. But how? There probably is a way. Where it needs to be part of ASM instruction, otherwise. But the ASM instruction, we can't. Well, there's enough space here to add additional data. Yeah. So if we could hammer in here the... What do we need to add? Executable PB types. So we need the line number, offset, and length. And this would also need information here maybe build function match collection. Function match collection. Function match collection. Yeah. Okay, so here we already have a map to look up the index to our matches with a function name. So ideally we use it here before we throw it away. Yeah, so I think in here we need to build, so we don't disassemble it. Right. So this just prepares. Function at index. Maybe this map needs to be part of the function match collection so that we can still look up this afterwards on another step. Maybe. Bit function match collection. How about we split this here off of this function? Have it as the next step. But then we certainly need this to be parts of the collection. to do, move to new function. Move everything after the new function. Okay. Okay, so basically our match functions, we need to post-process them after the disassemble step. Yeah, after disassemble step, we will need to build the links to PDB, to source lines. Okay, and what's the most efficient way of doing this? PDB reader. Well, we have a huge list of functions. We don't have a function lookup in here. Source file, intermediate, address to symbols map, also intermediate. We need a function name to function map, function name to function name to index map. Why is this called address to symbols map? I think this should be named symbol address to index map. Yeah, so for efficient lookup of functions, we need a map. Which we didn't have. Get functions. But do we really need a map? The thing is, when we build the bundles, then when we build the bundles, then we iterate the functions here. And here you would have an opportunity to make the link. To do fill source lines here. Yeah, so we can write to this bundle name matches. What is this? What is this? Match it. Huh? Build bundles. It would mean that we also had to collect, that we also had to pass matches here. Yeah. Yeah. So pass the matches here, pass them on here, match, function match, bundle, matches. Yeah. Function info. Yeah. So we have an opportunity here to build this. Yeah. Without the extra map and without saving this map here, we can then discard it. Yeah. Okay, this works. Yeah. Okay. And then basically in our function here, we need some function here to say, hold on. It needs to happen after disassemble step. So we first have to disassemble and then build a bundle. But that's a bit chicken egg problem. Because we want to have the bundle before we disassemble. Because there's a case to make that In the UI, we perhaps want to show bundles first before we start disassembling anything and doing real work. Shit. Okay, that's a problem. There are these interdependencies. I mean, we could always just do extra work and do one thing after another and like have a second time find, right? Look up. But yeah, it's extra work then. Okay, this is not an easy problem. Okay, before we continue thinking about this, let's already, we definitely, in function types, we definitely need this here, this info. So if we go to PDB reader, PDB types, so we have a line number, yeah, offset, line number, offset length, line number, offset length. Yeah, so with the offset and length, we basically match these lines. So we only need to store line number really in the assembler instruction, right? That's it, right? So then we go here. Function types. Where do we want to put it? Yeah, let's put it right after address. Line number 0. Line number in the source file. If exists. Line number in the source file if exists. Okay. Yeah. Good. And then we have source file info. I have a name. Checksum. Yeah, let's take the name. is this so big? Now it's smaller. Yeah. Debug. Begin address and address. Instruction code. Well, this will balloon the size. Yeah, I don't know. Source file name. It's quite big. I don't know. Well, yeah. Okay, so basically we would have here would have void set source file name name source file name equals name. Yeah. And then we also need we need set instruction line number. And then we have a size t instruction index and un16t line number. Good. And here we put assert instruction index smaller than instructions dot size. We already have a getter function for the instruction size. And then we say instruction index, 1 to 10. 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 1 dot. Oh, it's a variance, right? Well, we will do std get std get that is instruction. We do assert std holds alternative asm instruction. And then asm instruction that instruction dot line number equals line number. Okay, so it means that after the fact we can set the line number for individual instructions as we iterated. Yeah. Alternative would be that we pass it a PDB we pass it a function info vector. Or we pass it this one here. Yeah. Yeah, maybe that's a better idea. We add here a source line info vector. Source lines and we add a void set source file, and then we pass this thing source lines PDB source lines and source and source file info. PDB source file. Okay, I think that's a better idea. Yeah, let's remove this const. Okay, and then we forward declare class or structs. Structs. Okay. And then put that here. And then we do include PDB reader types. And here we implement so source file name equals pdb source file dot name, simple enough, and source pdb source lines. So I think what we do is we look through our instructions PDB source line info const source line wait, what am I doing here? Asm instruction variant then if std get if asm instruction variant it's not const, asm instruction so if instruction and size t source line index equals 0. Okay. Okay, how do we do the mathing here? Let's see. So we have offset and length. Offset from function address. Okay, so our function address, we know it's begin address. Let's put an assert here. Assert begin address is not 0. Yeah. Okay. Okay, so we want to yeah, so we need to check right. Okay, so the end result is that we want to set the line number here, right? Okay, so we need to check something like if instruction address is larger equal let's do for source line index smaller than PDB source lines dot size plus that, so it would eventually count up. Why is it complaining? No idea. So if our instruction so we have a loop. If our instruction falls within certain bounds, then we assign line number to, let's do PB source line equals PB source line info reference const source line lines index let's call this source line, and then it will assign source line number, right? And it needs to check, and then it will also break because it was successful. And it needs to check if instruction is bigger than, oh boy, is bigger than here, begin address plus source line dot offset and smaller and smaller than begin offset plus source line dot length, right? Let's double check length offsets. Offset is VA minus apps virtual. Well, it's a serious downcast, yeah. Yeah. Okay, so if address bigger than begin address plus the offset and smaller than begin address plus offset plus length, then it should be in there. The source line, the line number should belong to this. And then it breaks this loop. Otherwise, it will increment here this and check the next one. Yeah. Okay, and this way should work. Yeah. This looks like it could work. Why is this no operator matches? Huh? Const size t counts I don't know what's the problem here. Am I stupid? I don't get it. What is wrong with our for loop? Somehow I don't see it. It's probably something stupidly simple, but I don't see it. Huh? Let's press F7. Let's see what the compile error will be. Oh, source line index. My gosh. Stupidly simple. Yeah. Somehow I thought I increment the index. I didn't care to check the variable name. I only looked at plus plus because that's where the red wiggly line was, right? Yeah, not on the variable, just on the plus plus. Okay, so that is fixed. Okay, I think this works. Well, we can't test it right now because we don't have it hooked up yet, but I think this works. So we pass it the source file and the source lines, and that will just copy the string here, the name, and will then also copy the line number into each instruction that it finds. We should probably set an assert here for instruction line number, not 0, afterwards. Because if it is 0, then it would mean that the PDB file is out of sync or something like this. Yeah, it would mean that the executable and the PDB file are not of the same build. Right? Yeah. I mean, it's quite a bit aggressive to raise an assert then, because it's a data error. Typically, you shouldn't raise assert on data errors, but since we don't have any other facility to raise errors here right now, I guess it's good enough. Yeah. Good. Yeah. Okay. I think this is going into the right direction here. Yeah. Okay, let's remove this. All right. Good. Then, by the way, what about this thing here? What's this used? It is, yeah. Good. Yeah, so I expect that this will work. Unless, of course, we made a mistake. Yeah, which is always possible. Yeah, okay. Begin address. Maybe we should also assert that the instructions are not meant to be empty when calling this thing. Well, these asserts are also questionable. Like, basically, it makes assumptions that the caller should only call it after this and after disassemble. Well, let's make a set address range. Well, this should also have an assert for instructions. Instructions empty. And this actually here we can simplify empty, not empty. Why is this here? I don't know why this thing is freaking out here again. Probably because of this. Set address range must be called before this assemble. Or let's say can be called before disassemble. Set source file info set source file info can be called let's say must not be called after disassemble, but can be called before. Must not be called before disassemble, but can be called after. Okay, I think that is fair. I think then we can remove one of the asserts here, because this I think will be implicit. Begin. Yeah, I think we can remove this. Or we can keep it. Can add another assert here. Assert source dot empty, or maybe source lines dot back dot offset plus length smaller, or is equal to end address minus begin address. And of course it totally freaks out. Beautiful. Beautiful assert. Maybe we rename it to source file. Beautiful. Well, if instructions are not empty, then this shouldn't be empty either, right? Assert source lines also shouldn't be empty. Yeah, I think like this. Maybe. It's a lot of checks. Okay. Yeah. Okay, we spent a whole lot of time without getting much done. It's okay. Okay. Yeah. We spent way too much time on this. So slow. Okay, good. But yeah, we got some good thought in here. So next step, we will figure out how to pass on this to function, which we have to do in here, build bundle here. Hold on. There still was a problem. Right, we first need to disassemble. So we cannot just put it in here, because this happens before disassembling, because we don't disassemble here. So we need to disassemble and then do this. But then the problem is, then we don't have the bundles. We can't, well, make this const. Yeah, how do we solve this chicken egg problem? Because the thing is, I would like to keep this assemble step separate from this step here, because disassemble is expensive. There must be a way. Maybe I will have an epiphany in the next video. Yeah. Okay, let's think a few more minutes about this. Well, it should be independent of this, because this only determines bundle builds, but we can also build this bundle, right? If we have bundle type set to none, then this won't happen. It will do this, and in this case, it should still build this stuff. So we cannot do it here. We cannot do it here. Oof. Shit. Needs to be separate steps. Okay. After the disassemble step, if we keep this lookup map, this one here, if we keep this map, then we can use it after to once more iterate the bundle, the source files, iterate the source files, iterate source files. Yeah, okay. Then on this, to do optional out of string to index map. Okay, so we do this optional out of this map, so we have it. Then we move this into a new function, and then after the disassemble, which is here, we'll have a new here to do builds source line, source file association here. Okay. And then here we will have the string, the map, I mean, string to index map here. And we pass it to this function in here. And then we build the source file into the function matches. Which will put it into the ASM instruction vector. Yeah, after the disassemble step. Function match. By the way, why do we pass collection here? That's wrong. We should just pass this here, function matches. Let's rename this to function matches. 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 Okay. Okay. And here collection dot matches. Oops. There we go. Yeah. Okay, I think we have a plan. I think this will work, yeah. Yeah. Okay, it would be nice to code this now, but it's already quite late, so we have to do it the next time. I have now it mentally in my head, and I think it will work, and it won't be a big problem, yeah. Okay, good. Yeah. Okay, let's double check that we documented it properly. I'm pretty sure the next day I look at this, I already forget everything. Yeah, it's very likely. But okay, we put a bunch of to-dos here. This should help us. Yeah, this should help. Okay, good. I think we have a plan. And once that is done, then we can go to our ASM printer, and then we can think about how we print the CPP stuff next to this pen to string. Yeah. Comparison. Yeah, well, let's worry about this afterwards. We need to pass file contents or something here. I don't know how to do this yet. Comparison results. What is in here? Comparison records. Comparison records. Yes. Instruction variants. Here. Comparison result. How? Comparison records. ASM instruction. How do I get to the function? Result bundle. Oof. Output comparison results. In our result bundle, okay, I'm missing, I mean, link to instruction pair is good, but I'm missing the information for the source file. Where's that? How can I get that? Shit. Why do we lose it? Collection. Somehow we lose it. I mean, here it has compilant or source file name. Shit. ASM comparison results. Maybe we need to run comparison. Match functions. I think we have to add additional intel here. Like here we would have to add the source file name, I think. Yeah, right. Yeah, okay, let's add a note here to do add source file name pair or similar records. Yeah, so yeah, comparison record. So these contain pairs of instructions, and then we also need here a pair of source file name, or actually we can also link to function. We can have a, because this is already dependent on function. This, like, if the function object was destroyed, then this would dangle already. So here we can have a pointer std array const function to function pair, I think. Yeah. And then in the function pair, we have access to all the info that the function has. The source file info, the begin address, end address, instructions, and so on. Yeah. Yeah. We need this, yeah. Okay. I'm glad we solved this. I was panicking there for a moment, but this makes sense. We should be able to easily set. Good. Then, yeah, I will end it here. I hope you enjoyed. I wish you a great day or night until next time. Goodbye.